All right, ladies and gentlemen, let's try this. You should have out your notes, a pencil, and an extra sheet of paper for some additional practice problems that I'm going to give you that aren't actually in your note packet. So we are on 19.3, which is balancing redox reactions. If you see here, we have potassium metal reacting with water, and then we also have zinc metal reacting with hydrochloric acid. We can actually balance these reactions in terms of their exchanged electrons or the fact that they are redox reactions. So let's talk about the rules and how we make this happen and how we make this work. All right. So we use what's called the half reaction method. And if you look in your notes, there's 10 separate steps. Now I'm going to use example 4 to actually show you how these steps work. Okay. Now, still the first thing that you should do is assign oxidation numbers. Okay, that's still the first thing that you should do with these problems. So let's do that first. And we have to go back to how we think about our oxidation numbers. Okay, so when we are dealing with it, we are going to say oxygens are -2, remember? Okay, and we've got 7 of them, and this whole thing has to equal -2. All right, my ballpoint pen, I want to change to a felt tip pen. So, yeah, let's do that one instead. Okay, so that's a -14, and then we have to add 2 times x, which all has to equal -2. Okay, which will that make x a +6? So an oxygen's a -2. All right. And then we can go back down here. Let me erase some stuff. Okay, so we got those two. Then for the next one, we always know that hydrogens are +1 unless they are put with a metal. So these are not metals. So this is +1, this is +1, which gives me a total of a +4 right now. Then we know oxygen is a -2, so that's -2. This whole thing has to equal 0, so that will make my C right here a -2. Okay, so then I go back here to my Felty, and I erase. Okay. And then I do my oxidation numbers again on this other side. So again, +1, +1. So that's a total of a +2. This is -2, so that is a total of +2 and -4, and that has to equal 0. So since it has to equal 0, that will make the carbon now +2. And then this is a +3 because it's 9. So we look here and we say this has gone from a +6 to a +3, so it's become more negative, which means it gained electrons. I need to change the color of my pen. Can I change my pen color? Yeah, I can. Good. Let's change my pen color. All right. And that means it was reduced, and then oxygen stayed the same, but carbon went from a -2 to a +2. It became more positive, which means it lost electrons, which means that it was oxidized. So that's what we have to figure out first. What was oxidized, what was reduced? Because we have to write our reactions based on that combination or pairing. So we take our reactant, and I'm just going to start with the one that was reduced first. Okay, and the one that was reduced first was my CrO2, and actually I have this as, where's my thingy? Jeez Louise, this is taking a lot longer than I wanted it to. Okay, so after I do that, now I can write my half reactions based on what was reduced and what was oxidized. So my half reactions would be my reactant that was oxidized, or that was this one I picked to be my one that was reduced first. So my reduced one was my Cr2O7 2 minus, which became the chromate ion as the product. Okay, so that was my reduced one. Then I have my oxidized one, which was my CH3OH, which then became my HCO2H. Okay, that's methanol, by the way, that became formic acid. So just so you know, those are my half reactions. That's what we consider them because it's just talking about a piece of the reaction, and we always do it as one is our redox reaction, the other one was our oxidation reaction and what they became because they were oxidized or reduced. So that's our half reactions. Okay. Then we have to balance all the other elements that are not oxygen or hydrogen. So when we look at our first equation for our reduced reaction, then half reaction, then we notice that the chromates, there's two on the left side of the equation, but there's only one on the right side. So we go ahead and put a 2 in front of the chromate. The bottom one, carbons are balanced, so we don't have to do anything with those. Then we balance the oxygens. We do this by adding water. How many oxygens are in water? 1. So for example, on the first reaction here, I have 7 oxygens on the left side. So to get 7 oxygens on the right side, I have to add 7 waters. So that's why I put plus 7 waters. For the bottom reaction, I have 1 oxygen on the left and 2 oxygens on the right. So that means I have to add 1 water onto the left to now have 2 oxygens on the left and 2 oxygens on the right. So you just add water. You don't worry about whether it's how it's messing up the hydrogens or anything else. You just balance out the oxygens by adding water. Okay. Then we have to balance the hydrogens. We do that by just adding hydrogen ions. Okay, especially since this is in an acidic solution, it says acidic out next to it. That's going to be that we use hydrogen ions. If it says basic, we'll end up using hydroxide. But yeah, for the most part, we're going to choose hydrogen ions for now. So when we have to use hydroxide ions, I'll show you in a minute. But so I have 14 hydrogens on my first reaction on the right side. So I need 14 hydrogens on the left side. So I'm just going to add 14 hydrogen ions. All right. Now on the bottom one, I have 2 hydrogens from the water, and then I have another 3, so that's 5, and then I have another 1, so that's 6. So I have 6 hydrogens on the left. I only have 2 over here on the right, so I need to add another 4 hydrogens to the right to get my 6 on both sides. So far, I've written the half reactions by figuring out what was reduced and what was oxidized. Then I balanced all the elements other than oxygen and hydrogen. Then I balanced my oxygens by adding water. And then I balanced my hydrogens by adding hydrogen ions. All right. So that's where I've gotten to so far. Now the next step is to balance the charges. And we'll balance charges by adding electrons. So on my first reaction here, I have 14 positives plus 2 minuses, which makes a positive 12. On the other side, I have plus 6 because I have 2 times 3 positive. So I have to get the plus 12 to balance out with the plus 6. So to do that, I'm going to add 6 electrons to the left because that's going to take away positiveness. Okay, so that's 6 electrons plus the 12 on my left side here makes it to where I only have a plus 6 on the left side. I also only have a plus 6 on the right side of that equation. All right, now the bottom I have 0 on the left and I have a positive 4 on the right. So I have to add 4 electrons to balance that plus 4 out on the right side. Okay. All right. So we've gotten through 1 through 5. I've color coded them so you can kind of take your time and look at them. All right. So next, we're going to have to multiply the equations by a ratio so that the electrons are the same on both equations. So I'm looking for a factor that's going to allow me to have both 6 and 4 to where they'll cancel out. So to do that, I'm going to multiply them by 2 because 12 is going to be that common multiple that they have together. So I'm going to multiply the top by 2 and I'm going to multiply the bottom one by 3. Okay, so that gives me that common value. All right, so take a minute if you need to pause it here to just kind of look at the screen again to figure out where things have come from, then go ahead and do so. But you should have all of this written down on your notes at this point, okay, on those lines. All right, so number 7 says add the half reactions together. So I'm going to give myself a new screen here because it gets a little crowded. So all we're going to do is just distribute the 2 to everything in that first reaction, distribute the 3 to everything in that second reaction, and then we're just going to add it all down together. So add them all together. So that gives me 2 dichromates plus 28 hydrogens plus 12 electrons plus 3 methanols plus 3 waters. Then I get on the other side of the arrow 4 chromate ions, or chromium ions, excuse me, plus 14 waters, plus 3 formic acids, plus 12 hydrogens, plus 12 electrons. Okay, so that's just it added together. Distributed the factor, added it together. All the reactants on one side, all the products on the other. Okay, now you're going to cancel out anything that is the same on both sides. Well, I don't have dichromate ions on both sides, so it has to stay. I do have hydrogen ions on both sides, though. So I have 28 on one side and 12 on the other, so I'm going to subtract the 12 from the product side, and that will leave me with 14 hydrogens, or excuse me, 16 hydrogens. Then I have waters on both sides, and so I'm going to have 14 on the product side and 3 on the reactant side. So that'll change my waters to be 11. And I'll cancel out my 12 electrons. Okay. That is all I can cancel out. After I've canceled everything and reduced everything as much as I could by subtracting and combining like terms is really what I've done. Then I'm going to go ahead and write out my final reaction. Okay. In your notes, it says number 9 is if the reaction occurs in a basic solution, add hydroxide to both sides to cancel out the hydrogen ions. You'll make water on the side with the hydrogen ions, cancel out water if necessary. So this is an acidic solution, so we're not going to worry about number 9 for this one. And now we just need to check that both of the charge and the mass, or the number of the atoms, are balanced. So now we start looking to see if they're balanced. So as we look to see if they're balanced, we have 4 chromiums on both sides. Then we have 17 oxygens because we have 2 times 7, which is 14, plus 3 times 1, so that's 17 on that side. We have 11 plus 6, which is another 17 on the other side, so we're good to go on our oxygens. Then we have 28 hydrogens because we have 16 plus 6 plus 3. And then we have 22 plus 6 because we have 3 plus another 3, which is going to give you 28 on both sides. And then we have 3 carbons on both sides, so we're good to go there. Then we have to balance out our charges. So we have 2 times -2 plus 16 positives, giving me a plus 12 for my reactant side. And then I get 4 times a positive 3, and that gives me a positive 12 on both sides. So I'm good with all of that. So that is my final answer. and it's balanced. All right, that was a long example, wasn't it? So, hopefully everybody's still with me. Let's try another. All right, again, the first thing we need to do is go ahead and figure out what's oxidized and what's reduced. So when we do that, we are going to have to find our oxidation numbers. So if you need to pause this, go ahead and pause it, find the oxidation numbers, and figure out which was reduced and which one was oxidized. All right, so I went ahead and wrote them on here. Like I said, hopefully you did it on your own and you paused this. But nitrogen will end up being a +5 because oxygen is a -2 times 3 is a -6, and we need it to be a -1 overall. Then I2 will be 0. Then that's iodate. Iodate, which is IO3, is going to be a -2, so that's a -6, which makes the iodine a +5 because it needs to be a -1 overall charge. And then our nitrogen dioxide, oxygen's a -2. It's a neutral ion or a neutral compound, so our nitrogen has to be a +4. So that means my nitrogen went from a +5 to a +4, which means it became less positive, which means it gained electrons, so it was reduced. And then my iodine went from 0 to a +5, so it became more positive, which means it lost electrons, which means it was oxidized. Okay, so then our first thing is to write half reactions. So I'm going to do my reduced one first again. So I have my NO3 minus going to NO2. And then I have my I2 going to IO3 minus, or my iodine going to iodate. So next thing to do after we write our half reactions is balance any of our elements that are not oxygen or hydrogen. Nitrogen is balanced, iodine is not, so I need to put a 2 in front of iodate. Then I need to balance my oxygens by adding water. So I have 3 oxygens on my first reactant, my reactants of my first reaction. So I need to add a water for my NO2. Then I have 3 waters on the product side with my iodate. So I need to add 3 waters on the iodine side of my second reaction. Oh, sorry, 6, because 2 times 3 is 6. So I need to add 6 waters. All right. Then I got to balance out my hydrogens. So I have 2 on the first reaction. So I need to put 2 hydrogens on the reactant side. And then I have 12 hydrogens on the reactant side for my second reaction. So I need to put 12 on the product. And then I need to balance out my charges by adding electrons. So for the first reaction, I have to get it to equal 0. So I need to add 1 electron to the reactant side. Then on the second reaction, I need to get the products to equal 0. So I have plus 12, and then I have minus 2. So I need to add plus 10 electrons. Then I need to find a common factor between the electrons. So I'm going to multiply my first reaction by 10. Then once I do that, I'm going to add my half reactions. So distribute your 10 and add. So I get 10 of my nitrate ions, 20 of my hydrogens, 10 electrons, plus iodine, plus 6 waters, yields 10 nitrogen dioxides, plus 10 waters, plus 2 iodates, and 12 hydrogens, plus 10 electrons. Then we cancel out anything that's similar, which means we are going to reduce our hydrogens, so it will become 8 hydrogens. And then I'll cancel out my electrons, and I will reduce my waters.
That's completely simplified now. And so then I'm going to write what I've got left over. Then I need to check my atoms as well as check my charge. So I have 10 nitrogens, 10 nitrogens. I have 30 oxygens. I have 20 oxygens plus 4 plus another 6, which is 30. I have 8 hydrogens and 8 hydrogens. And I have 2 iodines and 2 iodines. So I have enough of my, so it's balanced. Then I have negative 10 and positive 8, which is going to give me a negative 2 for my reactant side for my charge. And then I have 0, 0, and negative 2. So I am balanced. All is well. All right, next one. Same thing. Got to find our oxidized and reduced first. All right, so oxygen's a minus 2. So that's minus 8. And it has to be a minus overall, so manganese is plus 7. Then we have a minus 1. Then on the product side, oxygen's a minus 2, so that's a minus 4. It's an overall charge of 0, so that makes manganese plus 4. And then iodine is 0. So the manganese gained electrons because it became less positive, so it was reduced. And the iodine became less negative, it became more positive, so it lost electrons, so it was oxidized. So then we're going to need to write our half reactions based on this. So I will write my MnO4 minus, which will yield MnO2. Then I will write my I minus equals I2, or yields I2. Balance out my non-hydrogen, non-oxygens. So I need to balance out my iodines. Then I need to balance out my oxygens by adding water. So I'll add 2 waters to the top. Then I need to balance out my hydrogens. So I'll add a hydrogen, or 4 hydrogens. Then I need to balance out my charge. So I will balance out, so I have plus 4 and minus 4, so that's 0. So the top one's good. Oh, sorry, no, it isn't. Oh, it's only minus 1. So I need to add 3 minuses, because plus 4 and minus 1 is plus 3. So I need to add 3 electrons to cancel out that charge. And then I have minus 2, so I need to add 2 to the product side of my second reaction. Then I need to find a common multiple, which is going to be my, it's going to be 6, so it'll be 3 and 3, or 3 and 2, to balance my factors out. Okay. So then I'm going to have my, I'm going to add them all together. Okay. I'm going to cancel out some things here. I'm going to be able to only cancel out my electrons at first. And so then I'm going to add these, but now I have these hydrogen ions, and I have this water on the other side, and I can't really do anything to reduce those. So I was told, though, that this one was a basic solution. And if you go back to our rules again, it says on number 9 that if it's in basic, we're going to have to add hydroxide ions to both sides to cancel out the hydrogen ions. All right, well, to cancel out hydrogen ions, I'm going to need, on the reactant side, I'm going to need 8 hydroxide ions. When I do 8 hydroxide ions, that's going to be 8 waters, really. So I'm going to add 8 hydroxides. When I do that, and then I'm going to add the same amount on the other side, because that's how many oxygens I'm going to have to do to balance out oxygens. Because I'm going to need, I just added 8 oxygens, I already had 8 oxygens. So, actually, no. Yeah. Yeah, so I had 8 oxygens when I did this. I had 8 oxygens here, and I had 8 oxygens here. So that's 16. I have 4 oxygens here, and then I have another 4 here, so that's 8. And this gave me another 8 oxygens. So when I look at this, then I'm going to have to look at the fact that um, when I combine these, that's actually going to give me 8 waters. So now I can reduce my waters on my other side, because remember HOH is really just water. So that's going to allow me to cancel out all 4 of those waters, and that's going to change these waters to only 4. And now that's going to leave me with the 8 um, oxygens, which um, I have 2 times 4 plus another 4, which that's 8 oxygens, plus 4 is 12. This is 4 plus 8, that's 12 oxygens. So the oxygens are still balanced. Then I have 4 hydrogens, 4 times 2 is 8, and then I have 8 hydrogens here, so those are still balanced. So everything's still balanced because I have 6 I's and 6 I's, 2 M's, 2 MN's, manganeses, 2 manganese. So all of those are balanced out. Now, though, I'm left with these 8 OHs, which makes it basic. So that's what you'll always have left over, is you'll have OHs left over versus H's. If you look at our other 2 examples, I had H's on one side or the other, so that made it acidic. This has OHs left over when I get done, so it's basic. Okay? So that would be my final answer of 2 MnO4 minuses, which is permanganate, plus 6 iodine ions, then plus 4 waters gives me 2 manganese dioxides plus 3 iodines and 8 hydroxides. All right. Now, that's a whole lot of stuff, and we've probably done most of class at this point. Okay, so I have 2 slides here that I'm going to recommend you write down on your extra piece of paper and work on your own. I will tell you the answers of them are posted on Schoology in these notes, so you can go back and check your answers for them. B is kind of tricky, but I will just tell you NO3 is going to be in both. NO3 minus is going to be in both reactions. So that'll just have to be a part of it, just to let you know. It'll be in both reactions. So, but this would be the acid ones. So write these 3 down. Again, if we need to pause it, we can. But write these 3 down on your separate sheet of paper. And I recommend practicing these. And then write these 3 down for your basic ones. Again, if you need to, rewind this and pause it so you can get them written, you can. All right? Work through the steps. Use the examples to help you. Okay? Again, if you need to go back to this PowerPoint, 1, I'll put the recording on Schoology. 2, I will also, I have just the PowerPoint on Schoology as well. So you can kind of walk your way through it again. All right? Have a good one.